Okay, so hi guys. This is for the recording now. We're going to talk about building video applications with Windows 8 with Windows Azure Media Services, or at least the output from Windows Azure Media Services. This is level 200, and today you have me, Nick Harris. That's my Twitter alias there. I'm a Windows Azure technical evangelist, and I work in Redmond. So the agenda for today. Today we're going to talk about media industry trends, so a bit of background before we get into working with our Win8 apps and media. We're going to look at some of what the Microsoft Media Platform offers. We'll talk or touch briefly on Windows Azure Media Services, but that's more of from the perspective of looking at the output from some encoding that's gone on in there. If you're really interested in the internals of Windows Azure Media Services, I'd recommend watching the session which happened this morning. All of that content will be online soon. So that particular session involved taking video, pushing it up through ingestion in media services, and then encoding and that sort of thing, and dropping out the output, which is what we're consuming. So did anyone attend the media services session? Awesome. You guys may be better experts at that than I am at the moment. But the real content that we're going to be sort of digging into a lot today is basically the media player platform framework for Windows 8. So this is the one-stop shop for getting that content surfaced up in your Windows 8 applications, and we'll have 6 or 7 demos on how to do that. So the demos include smooth streaming support, closed captions, so showing text for different languages on the subtitles of your videos, and how you can implement advertising with VAST and VMAP. So let's look at some of those trends. So what's changed for the media industry? So basically, we've got faster internet. So if you look at these stats here over the past couple of years, you can see that in 2011, we had online viewing down at like 1.4 there. I think that's a typo. But online, and in 2012, the online viewing has gone and surpassed both DVD and Blu-ray video. So what's more common now is people are, rather than going into stores and say hiring a, do you guys have VHS here still? No, I still got a couple. But rather than going in and hiring a DVD, VHS, a DVD, or Blu-ray, people are now using sort of online services like Netflix and Hulu, YouTube, or streaming video directly from their Xbox or IPTV. So we're now sort of starting to see this trend in industry whereby people are streaming video directly to their devices as opposed to going out and getting some physical media that they push into their machines. Right, so what else has changed? So besides faster internet, there's more devices now also capable of streaming content. So as it says here, for the first time, mobile traffic exceeded, or mobile video traffic exceeded 50% of all traffic for the first time in 2011, as far as going and watching videos. So it's expected that by 2016, 2/3 of the world's data traffic will be to mobile devices as opposed to, say, your desktop PC and those sorts of things. So we're certainly starting to see some trends emerging here. And basically, it's saying that mobile streaming is going to be one of the next big things. So another trend for the media streaming industry is basically HTTP-based adaptive bitrate streaming. So what this basically is it's a way to give end users, and we'll dig into it a little bit in a second, but it's a way to give end users a great or good viewing experience, perhaps much better than current progressive downloads. And we'll see examples of both of those through the demos. But basically, consumers want to watch videos online, anywhere, anytime, on any of their devices. Conversely, they don't want their videos to be streamed without having some buffering thing pop up on their screen. That can be frustrating. It actually happened to me in my hotel today while I was practicing demos. So while I was doing progressive download sort of stuff. But HTTP-based adaptive streaming is essentially a method that we'll talk about that is meant to help solve these issues that you'd sometimes see with progressive downloads on perhaps some poor quality internet connection. So let's take a look at HTTP-based adaptive streaming. Basically, it allows the stream to adapt your viewer's video experience based on the quality of network and the device's current CPU. So I guess, is anyone here really familiar with this at the moment? So, okay, bear with me. So some people may think this is basic, but to me as well, this was sort of something I knew nothing about 2 days ago, but now I do. So essentially, when we're streaming video using HTTP-based adaptive streaming, what you need to do is you take that original video source that you've perhaps recorded on your camcorder or on your laptop or whatnot, and you need to encode that into multiple bit rates. So you use a different bit rate for each different sort of video quality that you want. So it may be like 100 kbps for something that's captured on a phone versus 100 megabits a second for, that's interesting. That's my girlfriend. Please excuse me, otherwise I'll be getting a lot of messages. Hey, I am in a session. Please come back later. No. It's funny if you've watched any of my other ones, it always seems to happen. So can we like change my status here? Let's go to invisible. Okay, sorry guys. Awesome. So basically we take this video and we encode it into different bit rates, and that's such that we have some low quality bit rate for perhaps those poor performing networks, and also high quality bit rate for those people who have a decent network. But we take those that video that's been encoded in those different bit rates, and we basically put it on a stock standard HTTP server. So the encoding portion of this is something that you can do, say, with Windows Azure Media Services, and this is where I'm sort of saying what we're doing today is tying into the output of that. And that HTTP server in that case could be Windows Azure Media Services where the output is stored, but it doesn't have to be, it can be anyone. So let's say that now we've got that video and we want to go and start delivering that to our client applications. Now, what happens is it takes that one video, so you may have the, what have we got in the sample here, 200 kbps, 2 megabps, or 5 megabps, all over here. They come in as 3 separate videos, but your client application may start out and you say, I want to watch this video. So it may start at perhaps a low bandwidth. And what the HTTP server does in this case is it goes and chunks the video up sequentially into, typically it's a 2-second video chunk at that particular bit rate. Now let's say that after a few seconds, the user's, like he's hit play and boom, his video is playing. Now after a couple of seconds we detect that, hey, the network is really awesome, and perhaps the CPU is not really in use, so we know that we can up the bit rate. So what will happen then is some of these other chunks here will go off and it'll go out and start streaming at 5 megabits per second. Now let's say that the person accidentally or intentionally kicks off one of their downloading applications and they start downloading content. Well then dynamically what will happen is the stream will start and drop back to say 2 megabits a second, but they'll still be getting that content. So that's in essence how HTTP-based adaptive streaming works. Now, why is it good? Well, essentially this provides the best overall viewing experience. If you were to contrast this with progressive downloads, basically what happens from my understanding is when you start downloading the content, you're locked in at that one particular bit rate, so it can't change. So if your network is really good at the start and you start downloading using progressive download, you're sort of stuck there and you can't sort of roll over to a lower bit rate if your network changes, in which case you get the buffering picture coming back up and shaking your hands. So let's have a look here. This is progressive download as opposed to adaptive streaming. But while the other thing here is this diagram is more around the real cost cutting. So if you're a consumer sort of watching something, or if you're the content provider, with progressive downloads, you're watching the video, but you can see that that bar is actually downloading the video well ahead of time from what you're watching. So there's an excess cost in that. So if I hit stop or close the browser, I've already downloaded all that excess content, right? And me as a content provider, I've had to pay for the egress from my data centers for that. And me as a consumer, I've had to pay for the bandwidth on my internet connection to go and pull all of that in. So HTTP-based adaptive streaming, as we saw on the prior slide, it's sort of breaking it into those 2-second chunks. So you're not really getting all this excess video coming down. You're getting it sort of just a little bit ahead of time. So that also has scalability ramifications. So consider that you're not pushing all that excess data out through your perhaps data center. You're not going to be starting to hit your network I/O caps as fast because you're not streaming content that's not required. So currently there's 3 major streaming formats. All of them take H.264 as input. So this is essentially your MP4s that you get when you record content. Now to play these, we've got these nice little wrappers, which Ming-Fei has done to help remind me, but that H.264 is the input to produce these outputs, and this is something media services can do, but outputs that can be consumed by Microsoft Smooth Streaming, Apple HLS, and Adobe HTTP Dynamic Streaming. So one of the other emerging sort of standards that's coming out is dynamic adaptive streaming over HTTP, otherwise known as DASH. Now, the player framework that you'll see today, they're working on support for this emerging standard right now. So hopefully in one of the future drops, that will also be supported. So what else has changed? You may recall that basically in the past, everything's been about plugins. Now we progressed past that to sort of rich internet applications. So it used to be pure applications or media players, and now we've gone to a plugin scenario like Silverlight and Flash. But if you recall that sometimes even these scenarios aren't really that great. So this is the announcement of a very popular device. And you'll note that a couple years ago, and up on the screen here, you'll see that there's a little blue brick because some of the media on that page required one of these browser plugins to be installed. So the question is HTML5 the answer to this sort of plugin-based model? And the answer to that question, I guess, is it's still a little bit too early to tell. So if you look here, you can see that there's like 26% of the market still can't play HTML5. Only 50% of them support WebM or MP4, which, as we talked, was the input for your smooth streaming apps. Full screen support, well, not all not all devices or software and market can do that yet. And iOS is the only one to have natively implemented a streaming solution into their platform. And last, there was no digital rights management. So that's sort of important for those online providers that want to be selling content that lasts or expires after, say, 24 hours. Next one, the ecosystem. So this is a bit of a diagram about the type of ecosystem, and basically what I want you to have or get from this side is that I'd like you to consider sort of all the different kinds of devices that you need to perhaps consider for your solution, or that your solution may be able to go out and to deliver to. You've got PCs, you've got Windows Phone, you've got Microsoft devices, Xbox, you've got iPads, iPhones, all these different devices. So there's multiple endpoints and multiple delivery options, but also multiple monetization models. So part of our talk today will cover how you can have advertising within your application. So what about the reach story? So this sort of provides a more detailed view of, I guess, all of those endpoints and how you can reach them. So the Microsoft endpoints, we've got, say, Silverlight to browsers, we've got Xbox, Windows Phone, Windows 8, and you can see the supported protocols there being smooth streaming and Dash, or at least being one of the better ways to deliver that content. But we've also got a number of non-Microsoft endpoints, and we do provide some porting kits for those as well. And you can see there, you can target anything that supports Flash, iOS, or Android as well. So smooth streaming on Windows 8, this is an interesting diagram. It took me a while to get my head around. But basically, down the bottom, what you've got is the Windows 8 platform. And built into that, you've got a media pipeline. So this essentially provides you a way for you or your applications or native applications on the device to go and show video content. So those two items in the bottom in gray are sort of baked in. Now, you've got, like, say, the media element or the video element in your HTML5 or JS applications, and those ones natively just go and use that media pipeline. So you can now build out with those particular elements the JS HTML5 apps, C# XAML apps, or C++ applications that use video. But we really wanted to provide out-of-the-box a way to do smooth streaming. So that's not currently in the media pipeline for Windows 8. So you can't do smooth streaming out of the box in your, say, WinRT applications. You need to go and either implement something yourself or utilize what we call the Client SDK smooth streaming extension. So this thing essentially allows your applications to play back media that has a smooth streaming manifest. And then on top of that, we've gone and built out a player framework that essentially uses that, but gives you a nice media player which you can drop into your application, and that's what we'll be focusing on today. So let's go to the next one and have a little bit of a look at this Client SDK smooth streaming extension and how that works for those of you who sort of want to understand. So recall that item down the very bottom was the media engine on the Windows 8 platform. Basically, what you've got is a playback pipeline in there built into the OS. And it's got native codec support for those H.264, WNV, VC1, and a number of other formats. What actually happens is when your application goes to play one of those, it comes in, it hits the decoder, it'll go and use a renderer, a decryptor, and the thing that we've sort of got there for people who want to go out and extend this platform, say you wanted to utilize smooth streaming in your applications, is a media source interface. So this is an API that you can actually extend to build components. And this is what the media services team have done, and it provided the foundation essentially for the player framework that we'll see today. So they've implemented this interface, and it's essentially they've implemented it such that they can support a smooth streaming source. So if you set the source of your media player's source property to be smooth streaming manifest, so we'll see an example of this in one of the demos today, what would happen is that would come in and then it would be actioned, or it would essentially be routed through the smooth streaming extension SDK in this case, because we've registered that WAC manifest needs to go through this particular client SDK extension assembly. And that's how they've sort of added support for smooth streaming. So let's look a little bit on the player framework. So the player framework, which we'll be using today, is shipped as open source on Codeplex, on playerframework.codeplex.com. So if that's one of the key things you remember today, it would be that URL, because that will be what we're using for the rest of the time here. And it builds on the capabilities of the smooth streaming client, which we just saw, or the smooth streaming client extension. And it's available for multiple platforms. So we've got Win8 player in that framework that you can use within the 3 flavors of development modes if you wanted to build a store app. But there's also support for browsers and also Silverlight and Windows Phone. It's a well-established player framework. So I think they first released it about 2 years ago. And it's been used in major events like the Vancouver Olympics, is it NCB Sports? and the last 3 seasons of Sunday Night Football. So it's something that's being used in big apps, so you know that it's going to sort of work. And more importantly, it's also got a plug-in architecture. So if you only want to use advertising and smooth streaming, say, you just pull in those assemblies, and then that's what you get, and you're not increasing your package size there. And as we sort of saw before, this is basically the same thing that we talked about before. All right, so today there's all these different features supported by the player framework, but the key ones we'll focus on today are those in pink. She must have known my color, so she chose pink there. But we'll be doing closed captioning, advertising, smooth streaming, and also multiple audio demos. Actually, she's missed it there, but we'll also be looking at VAST and VMAP for embedding advertisements into your apps. So with that, we get to my comfort zone, which is doing demos in Visual Studio. So the first one we're going to do is Hello World, a Hello World video application using the Media Player framework. So let's do that. Let me grab a new instance of Visual Studio here. So I'm just going to start a new project, and we'll use HTML5.js. So we'll let that build there. Excuse me. So let me just show you what I've installed here first. Let me click on this link. There it is. So this is the Media Player framework on Codeplex. That's that link I talked about before. And I've essentially just gone and downloaded and installed it. So we'll now be using this to go and build out this application. So the first thing we need to do in our app here is to go and add a reference to the Media Player framework. So that's it there like that. We hit OK. So the next thing I really want is basically my HTML page here. So what I want to do is add a reference in this page to the CSS used to style the player that they give you, and also the player framework API that's provided in that. So the next thing we want to do is we want to go and actually drop a player onto the page. So let me do that. Let me format this a little bit for you. So you can see that the data win control in the first line of the div there is pointing to the player framework media player. Now, this div and this component essentially expects a video element in between the div, but if it's not there, it'll go and do that and drop that in there for us when it renders the page. Now, these properties, all of these properties are actually going to go and be set on that video element that the control is generating there. And lastly, the last thing we've got here is basically the source. So this will be an example of a progressive download. We're not using a smooth streaming manifest or anything like that. So that's that. So let's play it. So we just hit F5, and in those few lines of code now, we should be able to be pulling down a live video. Note how the progressive download is downloading all this extra content. Okay, I sort of really like that. I think it's one of the common videos people show doing these types of things. But that's our basic media player framework and the media player there being used in a few lines of code and streaming content over the net. So let's have a little bit. Sorry, I should clarify. Not streaming, but that was a progressive download, so it was pulling it down well in advance, and we saw that extra bandwidth that it was consuming. So if I had have killed that application before I was finished, there'd still be the associated cost with having downloaded all that content, even though no one was going to see it. So if we want to look a little bit further at what this control can do, I've got another sample here. And basically this one just extends it a little bit more, but sets a few more properties. So this media player is quite, I guess, rich in terms of providing out-of-the-box components that you can use to go and style the look and feel of that particular application. So you can see all of the properties here basically allow you to go and change the way that's going to be viewed by an end user. So in this case, what's changed is I've added the capability to skip between different playlist tracks. And you can see we're using the playlist plugin here to auto-advance, or allow auto-advance through the stream. But essentially, we've got a playlist with 2 items there, and we can click to and from them. So let's have a look at that and see what it's given us on the screen. I'll assume you don't want to watch it a second time. So let's see the customizations we've done there and skip to the next item in the playlist. You can see horses running on the beach and other things. All right, do you guys liking the documentary, or shall we continue with the presentation? All right. Some nice wildlife there. Right, so basically you can see we've added playlist capability, and again, it's just a few lines of code. So this control is really sort of making it quite easy to go and build these types of applications. But where its real power sort of comes in is when we go and start hitting the smooth streaming capability there. So the view which you saw there for clicking play, pause, and back and those sorts of things, it's all customizable as well. So you'll note that the player framework drops in this CSS here, and that basically defines how that's going to look on screen. So if you wanted to change the look of those buttons to perhaps be something, you know, a bit more branded towards what you're trying to do, it's just a matter of going and overriding these and providing your own sort of you know, PF container or whatnot, changing your background color and those sorts of things. So it's extensible and easy to sort of customize to your own look and feel. So that's the end of that first demo. So let me return to the deck here and see what we've got. So the next deck is demo is smooth streaming an asset from the cloud. So in this case, we've actually got the output from, say, the media services, from Windows Azure Media Services. So what's happened is a video's been taken, such as the MP4 we just played then. It's been uploaded and it's been encoded, and it's provided an output which is a smooth streaming manifest. And we're going to now build an application or extend our existing one such that it can go and smooth stream that content and basically reduce the amount of overhead in terms of the data that's being pulled down, but it'll also be able to go and now adapt to a bit rate that sort of works well with whatever my network connection is like. So let's do that. All right, and I'll go back to my demo script on the other screen here. Right, so to prepare the smooth streaming content, we've got a website. So I'll just show you this, and this is sort of an example of, it's an example that we've created at Microsoft, but basically it shows you what you can go and build out on top of media services. So if you wanted to go and start, and funnily it's taking a while to load there, probably shocking developers or something like that. She did warn me to preload the page, so I probably should have taken her advice. There it is. So this is a Contoso application that is going to demonstrate you know, that what we have is output from media services. So I think even in the media services session today, is this what Ryan used to perform the demonstration? So he would have uploaded content and had it processed here, and you would have got an output which basically would have been, in this case, something that's been encoded using smooth streaming, and it's published, so it's publicly available. So you can see now what I get from this output. So recall, we basically pushed video in to media services in the last session, and it dropped out this manifest, a smooth streaming manifest that we can now consume from our applications. So this is not supported out of the box in your Win8 store applications using the WinRT APIs. It was extended, as we previously talked about, using the client SDK extensions, and then the media player framework on top of that has made it easier to sort of consume this within, you know, a default looking sort of media player that you can customize. So what I need to do is I just need to take this manifest, and we're going to drop this into our application. So let's go back to our app. So what I'll do So I'll drop that in there so I remember it. Now, recall how we said that the media player framework is essentially a pluggable architecture. So what we've got there is, if you want adaptive streaming, well then you're going to have to go and select adaptive streaming. The other two dependencies that this has is this client SDK for smooth streaming and the C++ runtime package there. So by adding these three assemblies, we're now able to go out and build or utilize the smooth streaming capability of this media player framework. Now you'll note that there's a few errors here. Now some of these implementations are done and targeted to a particular CPU. So in this case, I'm using a 64-bit machine, so I'm just going to change that and give it a quick build there. And now that should be cleaned up. So what we need to do now as well is add a reference here to our adaptive.js script, such that it gets picked up in the page and the player will know what to do with it. And then the last thing, I'm just going to drop in a bit of a simpler snippet here without the playlists, just so we can sort of see what's going on. And I'll update this source to be that manifest. And we'll have a look at what's in the manifest in a little bit. So rather than targeting like an MP4 like we did originally, we're now going to a smooth streaming manifest. Now I hit at 5. Let's go full screen. And you'll note that there's no progressive download well ahead of time here. It's just purely going sort of live. You can sort of seek, but then everyone would miss the movie. Yeah. So you can skip forward and back, and it'll determine where you are in the stream. Pause. Can you force? Yeah, there should be a property to force that. So I'm not completely familiar with this. So I don't know if you were here when we started, but I've sort of picked up this session from a friend who couldn't get a visa yesterday. So I do believe that you can force or request a particular bit rate, and that would just be a property on the media player. I personally haven't tried it, but yeah, you should be able to do that, and it makes sense to be able to do that. But then you sort of, it's a bit of a catch-22 if perhaps people have a really awesome internet connection and you've set it really low, or if they have a really great internet connection and you've that's basically the same thing. Yeah. So I assume that property's there. I'd need to look at it, but basically Ming Fei has said that she will monitor her Twitter account, so if you guys want to start tweeting questions, she'll be there ready to answer as well. Certainly afterwards as well, I can take your business card and pass it on to her as well. So let's go back to the deck here. Let me close this guy. And we'll go here. So that was smooth streaming. Oh, sorry. The one thing that I think I did want to show you was what that manifest looks like. So let me open it up here. Where are you? It's just downloaded it on my other machine here. And there it is there. So you can see that there's, is this the right one? I may have grabbed the wrong one here. I believe that this may not be correct. So it's only really sort of a couple different bit rates defined in here, I think. So, oh no, there they all are. So basically that manifest is consumed by the player, and then it deals with it all itself. There's a number of different bit rates there. I certainly haven't sat down and read through these types of things too much because, as I mentioned, it's all sort of quite new to me, but I've at least got the capability over one day to be able to, see these applications working. So, I guess one thing to take away is you can at least get started quite quick, and moving forward, if you need to go and start looking at these things, then I'm sure that's a knowledge base you'll build over time. So let's jump back to the deck. So that was smooth streaming. So one of the other features that we provide in the media player framework is the capability to show closed captions. So if you wanted to support subtitles for multiple languages, there's a number of ways you can do that. You could just have plain text. You could have timed markup language. The TTML basically is the same as plain text. Plain text will show at the right times, but TTML adds the capability to also be able to go and style what that is going to look like in the case of this particular media player framework. And I think they're working on future support for those standards there as well. So what we'll do is basically we'll do a demo of adding closed captions to a video here using the framework again. So if I pull up that application, we'll drop into our next demo. So what we need to do here again is we need to add another reference to the appropriate packages for that. So if we come in and we scroll across here, I'm sort of working on two screens, time text markup there. I believe that's the only one we need, time text markup, and then hit OK on that. Let me just double check something here. Yeah, we're doing closed caption support. Right. And then I've got like the demo script all back to front here. My apologies. Right, so that's all right. So where did that guy go? Time text plugin. So let's drop this in. You know, I think I'm actually, I really do apologize, right? This is like that time when you're at uni or school and you're given an assignment, but you only find out about that assignment the day before, and then you got to get up in front of the whole class and basically present it. So I do apologize, as I said, a little bit flustered here, but yeah, I did pick this up rather than having them cancel the session. At least, you know, we can cover some of the content for you. So I think the closed caption support there that I was meant to do here is actually multiple audio streams. So that would be, you know, if you've got an audio in perhaps English or audio in something like Spanish or whatnot, you can also support that within your player. So let me see if I can find the appropriate item here. That's that. No, it's not there. 1 second. Okay, so media player, framework, manifest. Okay, that's better. Right, so I understand what's happening now. So this is another manifest. It is a smooth streaming manifest there, and essentially this audio track selection allows, if this manifest has or contains different audio tracks, this player will provide an option that you can basically click on, and that option will allow you to change the actual audio that's being played with the video. So let's spin that up and cross my fingers. But you can see that's the audio option there. And if we give it a little second to load, so it's starting to play now. This is a 10-minute video. So I may run away and cry while this plays. But let me change the audio. So let's start with Spanish and perhaps skip to somewhere in the video where we can hear people talking. You can do it. Perhaps network issue. Come on. All right, I think I may abandon this one, but I think you get the point. That manifest should have audio tracks for English, and what else did it pick up from the manifest? Direct to audio.
Tienes que aprender a escuchar. Esto no es ningún juego. Podríamos morir fácilmente aquí fuera.
Following along with him? Do you think?
I think Emo is trying to, but it's very hard to try to see the same thing that's in somebody else's.
Now, back to the English track. So essentially what's happening there is you've got that all defined in the manifest, and that was produced as part of the encoding that we've done in media services. And the player by default, just by saying, you know, is that audio selection property available, can then say, well, are the audio types supported in this manifest? And yes, it is. So then we can switch out the audio tracks quite easily just by changing that particular control there. So I think that's sort of pretty cool. All right, so back to the deck here, and we're going to start looking a little bit at advertising. So the media player framework out of the box has advertising support, and there's a number of different types here. So the first type that we've got is linear ads. So these can be presented before, between, and after video content, and they're in the full view of the video. So they're those ones that just are presented in full view, your video stops, and you see the advertisement. So before is called pre-roll, between is called mid-roll, and the end or afterwards is called post-roll. And these are all things that you can control. But let's look at some of the other types before we get into a demo. So that was linear ads. Non-linear ads are basically ads that run in parallel with the content that the viewer is watching. So it could be, in this case, it's a PNG or something transparent, the Xbox Live logo down the bottom. But it could be text or graphical banner ads, buttons, or perhaps even another video playing over the top of some portion of the screen. But that's what a non-linear ad is, something that runs in parallel and it's not sequential like a linear ad. So there's also this concept of a companion ad. So that's something that's, let's say, paired with a linear ad or a non-linear ad, and essentially it means that it's there and visible for the entire duration of the movie. So in this case, the companion ad would be that Xbox Live logo. So you can see on the left there that there's a linear ad and the Xbox Live logo is still visible. And then when you return back to the main content, the companion ad is still there such that the user can go out and click on it. So if you're looking for ways to monetize your applications and you are building these streaming-based apps, that are, there's certainly a cost to delivering that content out to your users. So advertising is one way that you can go and monetize that. Other ways that you could monetize it is perhaps by DRMing the content, which is also supported by the media player framework, and perhaps charge them for viewing of that content, such as how you can rent a video, say, from Netflix or other providers. So let's talk a little bit about the advertising standards that are supported by the media player framework. So the first one here is called VAST, and it's a video ad serving template. So basically it tells the video player what ad to play. It's recommended by what they call the Interactive Advertising Bureau, and that's the IAB, and essentially they're over 500 of the world's, or the US's, leading media technology companies. And they're responsible for basically selling 86% of advertising in the US. So this particular VAST standard goes and defines an XML template that you can use for defining, what the linear ad is that you're sort of going and embedding in there. Skippable linear ads are different from linear ads in that you can skip through the advertisement rather than having to watch it. Ad pods, as it says there, they're just a sequenced group of ads, so you can pack a number of advertisements into that one, ad. I guess ad pod is the appropriate name. Linear we talked about, non-linear we talked about, and linear with ad companions we talked about as well. But let's take a little bit of a deeper look at what VAST looks like. So essentially what you can see there within the creatives tag is that we've got a number of creative nodes. Now those particular nodes detail essentially what advertisements to play. So in this case, it's defining a linear ad and also a companion ad. And we'll come to the standard in a little bit that sort of defines how you can time when they are shown. But before we do that, let's sort of jump in a little bit here into, I think this is, so the linear tag here that you see in the top in the first red, this is what would be defined within that. So you can say that the advertisement is of duration 30 seconds. Tracking events and video clicks and such are those important things that get you money. So if a person clicks on the ad, within those nodes, there's going to be links out to whatever ad provider you're using that goes and tracks how many click-throughs versus impressions or how far through the video they watched. The last thing within there is obviously the actual advertisement. In that case, it's an Xbox ad. So let's have a look at VAST from the perspective of the media player framework. So for this particular one, let's grab this here. So I've got a pre-built demo for this because there's actually, to do this, there's a reasonable amount of code. And when we look at the next standard, you'll sort of conversely be able to see how much less code there is required to use VAST in conjunction with the next standard we'll look at. But what we've done here is we've just added a reference to the advertising plugin. So this is another one that comes with the framework. And you'll see, again, just references out to that. And then, again, the media player is quite simple and straightforward. So in this case, we've got a progressive download that we're going to use. It's just an MP4 sitting up there on the web. It's not smooth streaming or coming from a manifest anywhere. And if we look at the code behind here, you'll recall that we sort of talked about pre-roll ads, mid-roll ads, and post-roll ads. So the media player framework provides an API for you to go out and programmatically set, what those ads will be, or when they should play. And to define the content that's playing, you'll see that that's linking out to an XML definition that's somewhere out on the web. And that's essentially our VAST document that says, play ad X for a particular duration, and what happens when I click on it, where does it go? So let me open that up so you can see that it sort of correlates to what we saw on the slide. So you can see here that the media files for this particular ad, it's an Xbox one, but they're encoded at a number of different bit rates, so 200, 300, 700. And the delivery mechanism here is essentially a progressive download. You can also see a companion ad there as well. But that's basically the ad definition. And the media player framework knows how to read this. So if you wanted to switch this out online, you're essentially able to switch out the content of that file online. Perhaps, with a lot of advertisements, an advertising campaign perhaps only lasts 30 days. So the ad network that you would be using to deliver these ads, you'd get a new VAST definition from them. This is a standard, so most major advertising companies would support that. And you just take that file and it would be dropped directly into your storage where you want that ad displayed. Or alternatively, some of the major advertising companies also just give you, a public URL that has that content there, and you'd manage it through their sort of CMS type tool. But you can see we've scheduled a pre-roll, mid-roll, and post-roll ad, and then that's just been attached up to the media player. So if we hit F5 on this guy now, we should be able to see how that's going to embed that into some content. So first up, we should have a pre-roll ad. No relation to me.
Lego Indiana Jones and Kung Fu Panda.
Yeah, I don't really get the
I'm a PC.
but now this
And
is
I've
the
been
real
made into a
content.
stereotype.
So that was pre-roll. Now this is the video
I'm a
content.
PC, and I wear glasses.
I wear glasses.
Hey, I wear glasses.
I wear jeans. And I study jeans.
And I design jeans.
And now that's the mid-roll, and I think you get the point. The post-roll is going to occur at the end. All right, so that was VAST. So let's return back to the deck. I think if I just drop this guy out. Let's get a nice full screen going there again. So the last one that we have here is, and my slides have gone all crazy. There we go. Is VMAP. So VAST defined sort of the what, and VMAP defines the when. So when exactly do you want it to play within your particular video. So again, this is another standard recommended by the IAB. And what they sort of say here is it's useful when the content owner, doesn't have full control over the actual player. So consider that we're all developers, and perhaps we're purchasing rights to, sell perhaps Disney videos through our particular application. What this means is that Disney may want to sort of control or at least try and enforce a guideline to say, I don't want ads in every 2 minutes in The Little Mermaid. So what Disney would do is they'd provide a VMAP file that essentially defines when you're allowed or when you should be playing those ads. Perhaps it's only, a pre-roll ad and one ad partway through the video and then an end ad. Not perhaps, if people sort of tried to take control and exploit it, they'd be trying to put in a lot more. So VMAPs are good for that, defining when ads should be played. Obviously, it's hard for those content providers to go out and enforce these things because developers may go and perhaps, just point at their own VMAP or something like that. But it's sort of, a bit of being morally right, I guess, and following what they say as a standard. And I guess they could prosecute you if you didn't. But yeah, it defines timing for each of the ad breaks, how many breaks are available, the type of ads you can show, and how many are allowed in each break. So let's have a little look at what VMAP looks like here. So you can see in this particular one, there's 3 different ad breaks defined. The first one is at the start and it's linear. The second one there can occur 5% of the way through the ad, or through the main content. And the last one can occur, in this case, 15 seconds through. So that's an absolute time. But that's what a VMAP is. It's defining when those ads can play. And in conjunction with VAST, you can then say, well, I'm a content owner, like some big content owner that sells videos. I only want videos shown in these 3 points. Then me as a developer, I can go out and use whatever advertising platform I want for that content. And I'd have a VAST profile for that, which says what to play, and this thing coming from the content provider that says when I can play it. So they're used in conjunction to embed your ads when you want them, or when they should be defined or presented to the audience. So let's have a look at how we can do that. So that is the original app which I had. So let me build this one out. So we need to add a reference to the advertising framework here. So it's not there at the moment, so let's add a reference. And we'll go boom, that's advertising. Drop that guy in. We're going to need to reference this as well. Still don't quite like that automatic click-through that it gives there, but let's do that. So there's our advertising. Now the next thing that we need to do here is, I believe, drop in our video, which should reference out to a VMAP. So if you recall in the in our prior demo when we used VAST, that we had all this code that went out and defined, where's the VAST files that define the ads that are playing, and we had to do a whole bunch of code for when they would play within that particular advertisement. With VMAP, basically what we're doing here is we do have our original content, but we've also got a VMAP definition. Now, this definition will define when within the video those advertisements can play. But if I click into this as well, apart from sort of the VMAP, which goes and defines those videos, and somewhere down here we should be able to see the actual timing of those. Let me see here. Yeah, there's the 5%, there's the 15 seconds, and there's the start. But you can see that the VMAP is being used in conjunction with those VAST files, which we programmatically did in the prior examples. So now everything, the VMAP and the VAST, what to play and when to play it, is defined in one VMAP file here and some referenced out VAST files. So now our player only really needs to know where one of these things is, which is, in this case, the VMAP. So if I hit this now, there's no additional code behind. It's all being defined in markup in this case, and we should get the same experience as we had before, this time with Big Buck. I think you guys get the point. Let's click on it and see if it takes us anywhere. I might have missed the click there. Oh no. There's the mid-roll. Oh, there we go. There's the click working. And that particular ad takes us to total rewards. So that's sort of interesting. I wonder if anyone's getting money from that, since this is used in a lot of demos. But that was an advertisement, and you saw that Vast and VMAP together can define what to play and when. And this particular advertising provider, in their click-through within the FAST file, takes us to Hurrahs, which I think is in Vegas. All right, so that was Vast and VMAP. So let me go back to this. And again, I'm losing myself here. There we go. So that's VMAP. And then, so smooth streaming for Windows 8. So these are a number of, I guess, larger companies that are utilizing or building out solutions. Some of them are currently available, like QTV is available on Windows 8 at the moment. And these guys use the media player framework to go and deliver their content. So I think this is, I'm not sure, maybe French. But you can go and click on these. But at the moment, this was one of my demos. But it seems like they're geo-IP filtering, so you can't watch their content from New Zealand. But essentially, if I click in here, you'll see that they've got their own themed version of the media player framework, and we can go and hit play. And this is where we get blocked based on our geo region. But moving back to the deck here, there are a number of large companies. Some of them are companies that provide, say, live streaming video, like International News, and TV Boo Live, and other companies are sort of providing content like the one which we just saw there. So there's a number of different ways you can utilize media player framework, whether it's streaming live a live video, whether it's perhaps providing content such as a downloadable video. If you're using Windows Azure Media Services, as you may have seen in the session today, you can also go and sort of DRM the content such that it's only sort of valid for a certain period of time. But I think it's like 1 minute before wrapping up, so I'd like to sort of close on this one. So this is, I'm a developer, tell me how it's done. So essentially you want to really start at the playerframework.codeplex.com. Get the content there. There's a lot of useful documentation. There are some, the Visual Studio Gallery links, those next to it, just, you've got the links for them on Codeplex. Perhaps I'll show you one of the really useful resources that you should take away. It's Ming Fei Yan. And then this is Ming Fei, so she couldn't make it today for this session. Interesting. But this is her blog, and basically if you want to get started with media services and the media player framework, come here and follow some of the tutorials she's doing. All of the samples which we went through today, they're all available on her blog, plus there's a whole bunch more as well. Feel free to follow her on Twitter there as well. She's quite responsive in terms of if you have questions. Part there of her job being a PM is to also sort of field them, so she's doing a great job with that. And with that, I'll say thank you. If you do choose to submit feedback, please bear in mind that I am just standing in, so if it's very bad, please do not provide it. And with that, thank you for coming.